Jupiter is believed to be the oldest planet in our solar system. Current models of solar system formation suggest that Jupiter formed at or beyond the snow line, a distance from early sun, where the temperature was sufficiently cold for volatiles such as water to condensate into solids. The planet began as a solid core, which then accumulated its gaseous atmosphere. As a consequence, the planet must have formed before the solar nebula was fully dispersed. During its formation, Jupiter's mass gradually increased until 20 times the mass of the Earth, approximately half of which was made up of silicates, ice, and other heavy elements constituents. Then the planet started accretes mass from the nearby region. When the proto-Jupiter grew larger than the 50 Earth masses, it created a gap in the solar nebula. Thereafter, the growing planet reached its final mass in 3 to 4 million years. Scientists have put forward several hypotheses about the formation of Jupiter. Most notable is the Grand Tack hypothesis. According to it, Jupiter began to form at a distance roughly 3.5 AU, that is about 3.5 times Earth's present distance from the Sun, or about 520 million km. As the young planet accreted mass, the interaction with the gas disk orbiting the Sun and the orbital resonance with Saturn caused it to migrate inward. This upset the orbits of several other planets which were orbiting the Sun closer. This causes the planets to collide destructively. Then the Saturn began to migrate inward too, much faster than Jupiter, until the two planets became captured in a resonance. This changed the direction of migration, causing them to migrate away from the Sun, out of the inner solar system to their current locations. All this happened over a period of 3 to 6 million years. Jupiter's migration from the inner solar system eventually allowed the inner planets, including Earth, to form from the rubbles. Though there are several unsolved issues with this Grand Tack hypothesis, the resulting formation timescales of these terrestrial planets appear to be inconsistent with the measurement of the elemental composition. It is likely that Jupiter would have settled into an orbit much closer to the Sun if it had migrated inward toward the solar nebula. There are many competing hypotheses as well. Some of them predicted formation of Jupiter with orbital properties that are closer to those of the present-day planet, while others predicted the Jupiter forming at distances much farther out. Based on Jupiter's composition, some researchers suggested that Jupiter originally formed outside the molecular nitrogen snow line, or possibly even outside the argon snow line, which may be as far as 40 AU. Having formed at these extreme distances, Jupiter would have migrated inward to the current location. In these models, Saturn, Uranus, and Neptune would have formed even farther out. Then Jupiter and Saturn would have migrated inward. In conclusion, Jupiter's grandeur and mysteries continue to fascinate scientists and stargazers alike. Whether through Grand Tack hypothesis or other models, its formation, migration have shaped our solar system's history. As we ponder Jupiter's captivating presence, we are reminded of the vast unknowns that awaken our exploration and curiosity in this infinite expanse of the space. So thank you for watching this video. We hope that you found this information informative and helpful. If you have any questions or comments, please feel free to leave them down below. Don't forget to like and subscribe to our channel for more videos like this. And also don't hesitate to share this video with your friends and family who might find it interesting. Thanks for tuning in, and we'll see you in the next video.